చెప్పండి. నమస్తే నమస్తే. బాగుంది. ఓకే. చేస్తాం పాటు. అవునవును. అవునవును. అవును. చెప్తున్నారు. Now, all the working in the government and the value from the best yes, basically say, I will tell you who are those in the the most powerful question that is principal secretary in DM. There are only people in the problem. These are people in the population, but most of the portals are covered by the and you are in the key because of the national surrounded by the okay. Second background. Second background. That is actually not background. And that is the growing second growing second background Punjab typical and coming to this coming to those all three roads are going to be Mahanagar. Okay. All the that what is in mind most of the forest. It doesn't forest. All those rains are forest or bigger trees are coolness are air and most of the minerals are within the forest. You are exposed to the market. Now, after Straight on the side, and put the rock okay, and after that, they still on the walls. Okay, that's there now. The somebody can get the it's many like that. So that one, are the hours, they have started to everybody, awareness, everybody have awareness, and so many people are very, and out of time, people are, the irrespective you are, actually, there will be the compliments, outside also, what I tell them, like it, I mean, okay. How many times are there, actually, between the very and one, because having the range, that we can actually where rather than there, but it's the use of and you come into a carry. Then here, last, dialect because you should because you are coming with you have, you're replacing this, you're replacing this, service now. So I try to react to the different, you react to, that's
Good afternoon, everyone. I hope everyone had a good lunch. Lunch was okay? Okay. So in the first up session, we have seen about AI application in medical sectors. And then we have some hands-on session. Now today we are moving into our second session of today. It will be taken by Mr. Samu Nalam. So he is working as AI ML engineer in data safeguard company. And previously he was working with SecureSoft Private Limited as machine learning engineer. He is having more than 9 years of experience in AI and machine learning domain. And I can say you, he can be the best speech delivery will be by him only because his classes are always full of with students and he grabs the attention of student in a very nice way because I know him. I worked with him for last 4 years. So we were together, we have worked and I learned many things from him as well. We worked together and he used to take excellent sessions. So I hope you all will be engaged in his session. So whatever they have done project work for Odisha government, they have developed various projects for Odisha government on AI and ML domain. So he will be discussing on those points. So I hope the sessions can be interactive and you can just ask like how our students can as well do real-time project works like that. As our main aim is for faculty development is to make our student more enriched in this field so that they will be industry ready. That is the main focus focus of our faculty development. So I hope you can take some inputs from him. So where we should train our students and how can our students do such kind of project works, or where the internship opportunities are. Because I can tell you about Mr. Samunalam. He used to guide lot of students, and I think in his reference he has placed more than I can say 20 to 25 students from our end in different industries, IT industries, because he had a good network of connections, and he used to guide students that you can learn this thing so that you can have this career option. So he used to be an excellent guide for the students, and whoever attend his class, they will always remember that Saman sir is the best teacher, I can say. But he then shifted to industries. He is very good in AI ML domain as well. So I hope you will get benefited out of his session. So I would request our co-coordinator Aparna ma'am to felicitate our guest. Saman sir, please, can you be in stage? Thank you, sir.
Hello and good afternoon, everyone. I hope you all are not sleepy after having lunch. Okay, if you are sleepy, I'll wake you up. That's my responsibility. All right. So my name is Shamun Alam, and thank you, ma'am, for your kind words. I have been working into AIML domain for the last 5 years, and for the first 4 years or 3 years, I was employed here at CTTC Bhubaneswar, training students into various fields related to AIML, as well as Python programming and how web applications are built. Then I switched to industry and I joined SecureSoft Technologies Private Limited, which is a Odisha-based company which deals most of the products of government of Odisha. And then I switched to Data Safeguard. Recently, in just 1 month back, I switched to Data Safeguard, which is a company which protects customers or clients' data privacy. So this is a very interesting domain that I'm working on, and I'll be touching upon all of those points after some time. All right, but before that, we'll get on with what AI and what deep learning is, since the topic is deep neural networks and artificial neural networks. First half of this session, of this 2 hour session, 1 hour will be focused on the technology, the deep learning and neural networks in particular. And the second half will be a hands-on session where we will delve into the actual programming and actual coding and see how things are working there. All right, will that be fine? Okay, so let's move on. Sir, can you just switch to my system? Meanwhile, if anyone has any question in between, they can just ask. Without even raising your hand, you just ask your questions. All right? Okay.
तो ये सीन की तरह तो नहीं कर रहा। ये कहाँ से है? Okay. Sir, switch on to this. Wait. No, not there, not there. Touch is enabled, no? No, touch input is not there. Ah. Actually, I could not use PowerPoint on my personal system. So okay. So talking about deep learning, uh, how many of you have, I guess through all of these 3 days, people have introduced you about artificial intelligence, machine learning. So can anyone tell me what is machine learning or what is artificial intelligence? कोई बता सकता है? Anyone? Anything that you know of? Machine learning is subset of AI. Correct. Machine learning is definitely subset of AI, and deep learning is subset of machine learning subsequent. All right. तो ये ऐसा नहीं है कि are you all comfortable in हिंदी ना? Okay. So बीच बीच में मैं हिंदी आ जाता हूँ कभी कभी. All right. Okay. So what happens that artificial intelligence, the term was coined in 1958 by Alan Turing. So he said that artificial intelligence will be there, and artificial intelligence will be the technique that will enable computers to mimic human behavior. Mimic human behavior means it will copy human behavior. All right. But at that time, people didn't know how it will happen. What are the mathematical foundations of it? What are the statistical principles involved in it? Then in 1980s, first algorithms were developed called linear regression, logistic regression, and all of these algorithms were developed which specified like how this will be done, how machine learning will be achieved. And machine learning is term given to that where the techniques are there, how AI will be achieved. But still there were some drawbacks, some things that still could not have been done, like natural language processing. All right, like machines at that time, they were able to perform artificial intelligence tasks, but they were not able to understand human language. They were still able to understand computers language. All right. So to make machines understand human language, all of you have used chat gpt nowadays. Almost everyone is familiar with chat gpt. How is that possible? How is that chat gpt is understanding whatever I am saying in my language? Even if I say in hindi, even if I say in odia or any language, I don't speak correct english, still chat gpt is able to understand that. So to develop those techniques, some more research was done, and scientists came up with deep learning. So that is how this has advanced from artificial intelligence to machine learning to deep learning. And now we are talking about generative AI. And generative AI is nothing but a form of deep learning only. Okay, so the agenda will be of this whole session will be the tech back. Yeah, the definition of deep learning, then the techniques evolved. What are the techniques involved in deep learning and how deep learning actually works? Then applications. What are the main applications of deep learning nowadays? Then we'll come to smart network convergence theory, and we'll conclude with your questions and answers. Oh, this has to be on. So what are the vocabularies? What are the terms involved in deep learning? Deep learning, machine learning, artificial intelligence. This we already touched upon. Then these are some applications of deep learning. All right, deep belief net, artificial neural net, Boltzmann machine learning. All right, then supervised and unsupervised learning. That is a classification of machine learning where we classify what kinds of problems are there and how to deal with it. So supervised learning, what do you understand by it? Someone is label data. Correct, ma'am. So label data, what do we mean by label data? Inputs and outputs. What are inputs? What are outputs? See, with an example, very simple example, I'll tell you. Okay. For example, suppose I have to train a algorithm which identifies that whether this is the image of a cat or this is the image of a dog. Simple. एक मशीन लर्निंग प्रोग्राम है, कैमरा है, कैमरा के आगे अगर हम डॉग का इमेज रखेंगे तो वो डॉग बोलना चाहिए, कैट का इमेज रखेंगे तो कैट बोलना चाहिए, राइट? नाउ हाउ विल वी अप्रोच दिस? फर्स्ट अप्रोच, व्हाट आई कैन डू इज आई कैन टेक टू फोल्डर्स, दो अलग अलग फोल्डर बनाएंगे, एक फोल्डर का नाम रखेंगे कैट, दूसरे फोल्डर का नाम रखेंगे डॉग। डॉग वाले फोल्डर में सारे डॉग के इमेजेस, कैट वाले फोल्डर में सारे कैट के इमेजेस। फिर एक प्रोग्राम बनाएंगे, प्रोग्राम को बोलेंगे जाओ डॉग के फोल्डर में जितने इमेजेस हैं उनको देखो और याद कर लो कि डॉग ऐसा दिखता है। कैट वाले फोल्डर में जाओ, कैट के सारे इमेजेस को देख लो और याद कर लो कैट ऐसा दिखता है। जब वो हो जाएगी ट्रेनिंग, उसके बाद जब हम उसको डॉग या कैट दिखाएंगे तो वो बोलेगा ये डॉग है, ये कैट है। दिस इज कॉल्ड सुपरवाइज लर्निंग, दिस इज कॉल्ड लेबल्ड डेटा। हमने particularly we have defined what are dogs, what are cats. But if we go with unsupervised learning, we will take one folder, we will keep all the images in that folder, and then we will tell the machine learning algorithm go and separate those. जो एक जैसा दिखता है उसको एक साइड कर दो, जो दूसरे जैसा दिखता है एक साइड कर दो। ऑलराइट, दैट इज कॉल्ड unsupervised learning, where there is no label. So obviously you will tell that it will not be able to tell which is dog, which is cat. Yes, correct. It will not be able to tell which is dog, which is cat, but it will be able to tell these are same, these are same. All right. Now it has applications, several applications. Where are those? Where can that be applied? Have you ever gone to Amazon, done shopping, and then you see customers who bought this also bought this, right? So that is where this unsupervised concepts come in. In medical research, it comes in by taking in the features, what are the symptoms, and based on the symptoms, it categorizes in kind of illness. All right. So these people have similar symptoms. These people have similar symptoms. It will not tell it is malaria or dengue, but it will obviously tell these all people have same symptoms. These all people have same symptoms. All right. Same kind of illness these have, same kinds of illness these have. Similarly, it is done in movie recommendation or song recommendation on Netflix or Spotify. All right. These people like this kind of music. These people like this kind of music. They don't know which kind of music it is, but it is similar. So in such type of applications, unsupervised learning fits in. But where we have to do a particular inference, we have to say whether this is a spam email or this is not a spam email, where we have to identify whether the person is COVID positive or COVID negative. All right. Where we have to identify whether it is a loan fraud or not a loan fraud. In those applications, supervised learning is applied. All right. So every type of machine learning algorithm or every kind of machine learning technique has its own applications and set of areas where it can be applied, where it cannot be applied, where it is suitable, where it is unsuitable. Then we'll come to convolutional neural nets. Convolutional neural nets, I will be doing in the hands-on session. All right. There I will delve into a deeper architecture, how it is architecture is there. Recurrent and LSTM. That is a type of convolutional neural networks. LSTM, long short-term memory, is always used for natural language processing where there is predictive text or where there is semantic data. For example, the data that is coming now has relation to previous data. For example, if we talk in a sentence, so the next word has relation to all of the words that are spoken previously. That type of data is called semantic data. All right. So when there is a semantic data, LSTM comes into play. Activation function is will come when we deal with convolutional neural networks. Then these are the libraries and frameworks that are very popularly available for neural networks or deep learning. TensorFlow, Caffe, we have Theano, PyTorch. DL4j is not used nowadays. It's obsolete. Mostly nowadays, TensorFlow is very popular. TensorFlow is mostly used. Even ChatGPT is built on TensorFlow, or other most general applications about machine learning or deep learning you see will be built on TensorFlow. All right. So next. Okay. So this is a broad classification of machine learning. Artificial intelligence is divided into machine learning. Machine learning is further subcategorized into supervised and unsupervised and reinforcement learning. Now we come to supervised learning we dealt with. Unsupervised learning we dealt with. What is this reinforcement learning? Back, sir. This is not working actually. Huh. Sorry. What is this reinforcement learning? Hmm? Feedback based learning. Correct, sir. Feedback based learning. Let's come back to the same example of dog and cat. I want to train a machine learning algorithm to identify dog and cat. All right. First technique, I took images of dog in one folder, cat in another folder, told the machine learning algorithm to go read, learn, and then classify. Tell me. Second technique, I took all of the images in one folder and asked machine learning algorithm to separate. Third technique, I will take a camera. I'll show the camera image of a dog without training. All right. I'll show the camera image of the dog and ask the machine, what is it? Machine will say either dog or cat. If machine says dog, I will give +1 mark. If machine says cat, I'll give -1 mark. And I'll do this hundreds of times, lakhs of times. All right. Once it is trained, it will identify, it will learn to reduce the negative marking. And once it learns to reduce the negative marking, it will correctly identify which is dog, which is cat. And that is simply called reinforcement learning. Most of the generative AI applications are based on reinforcement learning. Not most, all of the generative AI applications are based on reinforcement learning. All right. Whenever we go to ChatGPT and we chat, there is also an option where we can rate that chat. Was this chat helpful or was this chat not helpful? All right. We might not give feedback, but hundreds of other people gives feedback. And the trainers who are working at OpenAI, they regularly go ahead. Their job is to chat with ChatGPT and rate the chat. All right. And based on the ratings, ChatGPT improves itself. That is a form of reinforcement learning. All right. Then what is deep learning and shallow learning? It's nothing but the number of layers in the neural network. We will come to neural network in a bit. All right. So if the number of layers are increased to 15 to 20 layers or more than that, then that is called deep learning because the architecture is deeper. And if it is 1 or 2 layers, then that is called shallow learning because the architecture is shallow, not deep enough. All right. Next. So deep learning is a computer program that can identify what something is. That is one line definition of deep learning. What something is. Whether what something is means what is the image of, whether it is horse, aeroplane, truck, cat, dog, whatever the image is. Or if someone has said something or if someone has written a text, what does that text mean? All right. So that is one line definition of deep learning. But in technical terms, it can say that it has a cascading effect of layers. There are multiple layers which will be trained. Each layer is doing its own job of extracting a simple feature from the image. For example, let's talk about this bottle. Okay. What do you see? A bottle of water. It has a shape. Yes. It has a texture. Rough edges are there. It has a color. It has an edge. It has a transparency. So all of these are called features. Okay. Now each layer, when we talk about layers or cascade of tires, each layer will identify one feature. It might identify the shape. It might identify the outline. It might identify the color. it might identify the depth, it might identify the texture. And depending upon all of those identified features, it identifies this is a bottle. That is, in simple words, deep learning. Okay. So, theory. For example, this I will come to later on. Go on. Okay, these are the features that I was talking about. For example, this is a car. Now, these are three different layers in the deep learning architecture. First layer will identify broader features: the shape, the outline, the color, the texture, the depth of the image, shadow, not shadow, light, everything. The second layer will further classify each or further delve into each of the features identified, like here tire is identified, here some circular shape is identified. Then it will be more abstracted in the next layer. All right. So slowly we go from a particular image to the abstract form of the image to more abstract, and finally we reach to an end where it can identify whether it is a car or a truck or aeroplane, whatever it is. All right. So we will be creating an image recognition system in this after just some time. All right. Let's move to the next slide, sir. This we have already seen, field of artificial intelligence, machine learning, then deep learning. Okay, so deep learning is built out of this. Now, what is the concept here? The concept is that we have just one neuron, one kind of neuron. There are not more than one kind of neuron. There is just one kind of neuron. Neuron is the nervous system, nerve cell of our body, right? है ना, मैम? You're from KIMS ना? ना? आपको पता होगा न्यूरॉन क्या होता है ना? हाँ, आप देखिए नींद नहीं आएगी आपको. No, it just in lunch we were having a conversation. Ma'am is from KIMS, so she must be interested in medical biology, right? है ना? हाँ. तो मैम सर मत बोलो मेरे को, आप बड़े हो, ठीक है? हाँ. तो ये न्यूरॉन क्या होता है ना, नर्वस सिस्टम का सेल होता है. अभी एक सेल होता है एंड यही सेल अलग अलग तरीके से कंबाइन होता है एंड अलग अलग चीजें कर देता है. It is running us, right? It is running us. We can see because of this cell, we can hear because of this cell, we can touch because of this cell, we can taste because of this particular cell in different configuration. क्या चेंज होता है? इसका कनेक्ट होने का तरीका चेंज हो जाता है. कनेक्ट होने का तरीका चेंज हो गया, वो दूसरा सेंस क्रिएट कर दिया, राइट? यही कंसेप्ट है मशीन लर्निंग, डीप लर्निंग या न्यूरल नेटवर्क के पीछे. That there will be one simple unit. If it is combined in different architecture, it will result in different results, outputs. That is the basic concept. And अगर इसके concept को हम देखेंगे थोड़ी देर बाद, तो ये इतना simple concept है, इतना simple concept है that इससे simple concept mathematics में हो ही नहीं सकता. That is a simple line equation. All right. That is the beauty of neural network, that a simple linear equation, the equation of a straight line, does all of these. The equation of a straight line drives a car. The equation of a straight line does the work of ChatGPT. It generates images. And आजकल Photoshop का एक advanced feature आया है, देखा आप लोगों ने? You type and it will generate the image. All right. You are there in a t-shirt sitting on your grill and you say that make me appear like I'm in a business meeting, and it will give coat, ties and everything. It will generate your image with that particular setting. All right. So, and it is all done by this neural network. Where did it go? It is all done by this neural network. And this neural network is nothing but a simple line equation that we will see sometime later. So that is the beauty कि एक simple architecture को लेके अलग अलग combination में combine करेंगे तो अलग अलग results हमें मिल जाएंगे. And that is why it's called deep learning and neural networks. It is inspired from neurons, that is why it's called neural, and it is a network of these simple perceptrons, so it is called network. So that is why the term neural network. All right. So without wasting much time, can I have a whiteboard here, sir? कैसे आएगा? I don't know. Most of you might be okay. Most of you might be familiar with this. So just pardon me if I'm repeating. See what happens. अरे, पेन नहीं है सर इसमें. अच्छा ठीक है. व्हाइट ले लिया मैंने. अच्छा दिख रहा है ना? ओके. ये ऐसा क्यों चल रहा है? नहीं, साइज तो ठीक है. पेन पेन टूल नहीं है, पेंसिल है और ब्रश है. अच्छा, ये क्या ओपन कर दिया मैंने? तो कुछ और कैसे ओपन होगा? ये था क्या? हाँ. हाँ, ये सही है. थैंक्स सर. हम्म. अभी दिख रहा है ना? ये होता है न्यूरॉन, राइट. और इधर से क्या मिलता है अपने को? इधर से अपने को इनपुट्स मिलता है, और ये इधर से हमें आगे पास कर देता है मैसेज. सिमिलरली आवर न्यूरल नेटवर्क इज वर्किंग, बट ऐसा नहीं करता है, वो बस दिखता है ऐसा है. ऑलराइट. मैथमेटिकल न्यूरल नेटवर्क क्या होता है? फॉर एग्जाम्पल, suppose we have something like age, and we have blood sugar, and here we have diabetes. Age is 35, blood sugar let's say 15, diabetes is let's say, yes. मैं वन ले, अरे सॉरी, one means yes. Okay. Age is, let's say, let's assume age is 20, blood sugar is 5, diabetes is no. Just an example. And like this, we have record of thousands of patients. Okay. First of all, ये कितनों को पता है? यहाँ सर आपको पता है ना? हाँ. Okay. Yeah, but we will be doing it through neural networks. Okay. So correct me if I'm wrong anywhere. All right. Sir is sitting to validate my points, whether I'm telling correct or not. झूठ बोलूंगा पकड़ा जाऊंगा. Okay. Now, in neural network, how we will do this? For example, I consider this age as x1 and x2, blood sugar as x2 and age as x1, and diabetes is our y. This is what we have to find out. यानी हमें नहीं, हमारे मशीन लर्निंग या एआई को पता करना है कि उसको डायबिटीज है या नहीं है ना? दैट इज व्हाट आवर न्यूरल नेटवर्क हैज टू डू. हाउ इट विल डू इट? We will take two nodes, x1, x2. Now this is called input layer. Input layer. ठीक है? It will have the inputs x1 and x2. These two inputs will go to a hidden layer. This is called hidden layer. Alright, बस नाम है hidden. Hidden कुछ होता नहीं है. दोनों इनपुट्स यहां जाएंगे. यहां क्या होगा सर? मैं भूल गया. प्रोसेसिंग. प्रोसेसिंग में क्या होगा? What? It will check what? No. ब्लड शुगर चेक करेगा. कैसे? विदाउट ब्रेकफास्ट और आफ्टर ब्रेकफास्ट. हाँ, वेटेड फंक्शन. करेक्ट मैम. हियर सो वेटेड फंक्शन विल बी नट. अरे मैंने डिलीट दबा दिया. वेटेड फंक्शन इज नथिंग but something called w1 x1 plus w2 x2 plus some bias b. Let's call this equal to s. ये होगा यहां पे. ऑल राइट, ये होगा यहां पे. एंड द वैल्यू ऑफ दिस s, देखिए अभी क्या है ना, ये w1 w2, these two will be randomly decided by the neural network to be a number. So for example, for the first time हमने decide किया w1 equal to 0.01, w2 equal to let's say 0.4. That will be randomly decided by the neural network, randomly as a starting point. All right. And then there will be one b, a constant. ये कांस्टेंट होता है ना जो हर इक्वेशन में कहीं ना कहीं से आ जाता है. सो दैट इज योर कांस्टेंट. लेट्स कॉल दिस कांस्टेंट समथिंग लाइक 3, a number randomly decided by the neural network. All right, so now this w1 is a number, w2 is a number, x1 is a number, x2 is a number. All right, b is also a number, so s will be one number, right? We will have one numerical value for s. That will further be fit into a very well-known algorithm function called sigmoid function. One upon 1 plus e to the power minus s. Right? Very well-known function, sigmoid function. अभी क्या होगा? ये भी एक नंबर निकलेगा, यहां पे भी एक नंबर निकलेगा, right? And this number, because of it being into a sigmoid function, it will be a value between 0 and 1. So that will give the probability, and that is the output. अगर probability 0.5 से ज्यादा आया, it is diabetic. 0.5 से कम आया, it is non-diabetic. All right. So what is this? ये पेंट में घुसा देगा ना, इस पेन का कलर अच्छा यहां से हो जाएगा ना. So what is this particular thing? Is this not a line equation? It is a line equation, linear combination, an equation of 1 degree. All right. Now how this is working, मैं न्यूरल नेटवर्क को बोलता हूं एक बहुत बड़ा फॉर लूप. It's nothing but that only, a simple for loop. What it does, how it will work, first of all, it will take, this age in x1 and this blood sugar in x2. Okay. and then using these weights and biases, it will calculate an output. Let's say the output using these weights and biases came to be 0. Huh? Then it will take another x. Second वाला लेगा, सेकेंड वाला x लेगा, सेकेंड वाला ब्लड शुगर लेगा, फिर इन्हीं वेट्स को यूज करके एक आउटपुट निकालेगा जो वेट्स ऑलरेडी प्री डिसाइडेड है. किसने डिसाइड किया? न्यूरल नेटवर्क ने खुद डिसाइड कर लिया. ठीक है, उनको लेके एक और आउटपुट निकालेगा. लेट्स से ये आउटपुट आया 1. ऑलराइट, इसी तरीके से जितने एक्स हमारे पास होंगे, जितने पेशेंट्स होंगे, फॉर ऑल द पेशेंट्स इट विल जनरेट वन आउटपुट. ऑलराइट, एंड देन it will compare this output to the correct output. If the comparison is correct, it will do nothing. If that doesn't match, it will come back and change this weight and biases. Again repeat the whole process. अच्छा, ये मैं रिपीट करूं या वो रिपीट करेगा? अच्छा, अगेन रिपीट. ठीक है. सी मैम, हमारे पास बहुत सारे पेशेंट्स का एज और ब्लड शुगर दिया हुआ है, साथ ही साथ ये भी दिया हुआ है कि वो डायबिटिक है या नहीं है. ये सब अपने पास डेटा में दिया हुआ है क्योंकि ये सुपरवाइज्ड है. ऑलराइट, सो वी ऑलरेडी हैव दैट डेटा. नाउ व्हाट न्यूरल नेटवर्क विल डू, दिस सिंपल आर्किटेक्चर दैट वी हैव क्रिएटेड, इट विल डिसाइड दिस W1 W2 एंड B रैंडमली कुछ भी डिसाइड कर लेगा. तो जैसे हमने रैंडमली डिसाइड किया 0.1 0.4 और 3, वैसे वो भी कुछ रैंडमली डिसाइड कर लेगा. आफ्टर डिसाइडिंग इट रैंडमली, इट विल टेक दीज इनपुट्स. सो इट विल टेक दिस, क्या फूटा? सो इट विल टेक दिस एज 35, x1 की जगह 35 रखेगा, x2 की जगह 15 रखेगा. ठीक है, ये इक्वेशन का वैल्यू कैलकुलेट करेगा. मैम, हाँ, इस इक्वेशन का वैल्यू कैलकुलेट करेगा यूजिंग 35 एंड 15 एज वैल्यूज. देन इसका वैल्यू निकलेगा. ऑलराइट, एंड डिपेंडिंग अपॉन वॉट एवर द वैल्यू, इट विल जनरेट अ प्रिडिक्शन कि डायबिटिक 0 होगा या 1 होगा. सपोज करते हैं उसने प्रिडिक्शन निकाला 0. ठीक है, देन इट विल टेक द नेक्स्ट वन. अब की बार x1 की जगह 20 रखेगा, x2 की जगह 5 रखेगा. यही सेट ऑफ वेट और बायस, सेम सेट ऑफ वेट और बायस को यूज करके एक प्रिडिक्शन निकालेगा. लेट से प्रिडिक्शन आता है 1. ऑलराइट, अब जो एक्चुअल, ऐसा वो सबके लिए करेगा. 100 150 1000 10,000 पेशेंट्स होंगे, सबके लिए सेम प्रोसेस करेगा. ठीक है, कंप्यूटर है, कर सकता है, बहुत फास्ट करेगा वो. राइट, हमें नहीं करना है. उसके बाद क्या होगा, ये और इसको मैच करेगा. दिस इज कॉल्ड ग्राउंड ट्रूथ. पता चल रहा नाम से, जमीनी हकीकत, रियलिटी है वो. राइट, सो इट इज कॉल्ड ग्राउंड ट्रूथ एंड दिस इज कॉल्ड प्रेडिक्शंस. So what it will do? It will match the ground truth with the prediction. मैच हुआ तो ठीक, नहीं मैच हुआ तो आके इसको चेंज कर देगा, या ऑटोमेटिकली. ठीक है, वो आके इसको चेंज कर देगा. जब तक वो चेंज करता रहेगा. ऑलराइट, जब तक वो चेंज करता रहेगा, सो दैट इट अचीव्स अ ऑप्टिमल सेट ऑफ वेट एंड बायस. ऑलराइट, एंड देन आवर वर्क इज डन. एक ऑप्टिमल सेट ऑफ वेट एंड बायस मिल गया, मतलब ग्राउंड ट्रूथ और प्रेडिक्शंस मैच हो गया. दैट मींस इट हैज बीन ट्रेन्ड. और नॉट ऑल द वैल्यूज मैच करना आइडियल केस होगा. ऑलराइट, बट 80% 90% इट विल गिव यू एन आउटपुट ऑफ एक्यूरेसी कि हाँ 80% एक्यूरेट है, 85% एक्यूरेट है. ऑलराइट, तो वो मैच करेगा. सो जब ये डेटा इधर से इधर फ्लो कर रहा होता है, दो डायरेक्शन में डेटा फ्लो कर रहा है. एक डायरेक्शन है when we are taking in the inputs from here, generating a prediction. So that is called feed forward. So feed forward में क्या होगा, जो एक्चुअल फीचर्स हैं, these two are called features. फीचर्स, ठीक है ना, फीचर है, किसी का एज, ब्लड शुगर, उसके डायबिटिक होने के लिए फीचर है. सो सारे फीचर को लेकर के वो आगे फॉरवर्ड करेगा, प्रोसेस करेगा. प्रोसेस का मतलब है ये लीनियर कॉम्बिनेशन का वैल्यू निकालेगा, एक्टिवेशन फंक्शन के थ्रू पास करेगा और एक आउटपुट निकालेगा. दैट प्रोसेस इज कॉल्ड फीड फॉरवर्ड. देन इट विल कम बैक एंड मैच इट with the actual ground truth values, and if it is matches, okay, if it doesn't match, then change the weight and bias. This is called what? Back propagation. Correct, sir. Back propagation. So using this complete cycle of feed forward back propagation, feed forward back propagation, feed forward back propagation, it is able to achieve an accuracy. ठीक है ना, सिंपल, बहुत सिंपल आर्किटेक्चर है, बहुत सिंपल फंक्शनैलिटी है, but yet it is able to achieve multiple tasks. How? This one set जो मैंने बनाया अभी, this one set is called perceptron. ऑलराइट, जैसे नर्वस सिस्टम का स्मॉलेस्ट यूनिट न्यूरॉन, वैसे आर्टिफिशियल न्यूरल नेटवर्क का सबसे स्मॉलेस्ट यूनिट परसेप्ट्रॉन. ऑलराइट, सो दिस इज वन यूनिट. नाउ दिस वन यूनिट can be multiplied or can be combined in several combinations to make a larger neural network to achieve larger tasks. Got it? That's very simple. तो देखते हैं. फॉर एग्जाम्पल, एक परसेप्ट्रॉन यहां हो गया, एक परसेप्ट्रॉन वही सेम x1 और x2 का, दूसरा परसेप्ट्रॉन यहां हो गया. ठीक है, अब इन दोनों परसेप्ट्रॉन के आउटपुट को हम ट्रीट कर लेते हैं, लेट्स से एक इनपुट फॉर दिस बिगर परसेप्ट्रॉन. ऑलराइट, तो ये मल्टी लेयर्ड न्यूरल नेटवर्क हो गया. ठीक है, इसी को ड्रॉ कैसे करते हैं, तो x1 और x2 वहां बार बार रिपीट हो रहा है, इसीलिए डायग्रामेटिकली दिस इज ड्रॉन एज x1 x2 and those two, this is the first hidden layer and this is second layer. तो इसको हम ऐसे ड्रॉ कर देंगे कि फर्स्ट हिडन लेयर में दो नोड्स ऐसे गया, देन सेकेंड लेयर में सिंगल नोड, ये ऐसे आया, यहां से आउटपुट निकल गया. राइट, बट द सेम कैलकुलेशन विल हैपन अगेन, क्योंकि इसका आउटपुट भी एक सिंगल नंबर होगा, तो इसको अगर हम x3 बोल लें और इसको x4 बोल लें, कोई नुकसान नहीं है. ऑलराइट, सो हियर इट विल बी w1 x1 plus w2 x2 plus some bias. Here it will be, let's say, w3 x3 x1 plus w4 x2 plus some bias, and then here it will be w5 w6, ऐसा कुछ हो जाएगा. Right, so at every node we have just one linear equation. At every node we have just one linear equation. All right, let's see it in some more context. Actual working देखते हैं इसका. अरे यहां जाएंगे, नहीं नहीं, सिस्टम चाहिए. अरे क्लास लिए हुए ना, 1-1.5 साल हो गया मेरे को, सब टीवी भी भूल गया हूं मैं. मेरा कनेक्टेड है। किसी ने ये दिखाया है आपको इस सेशन के दौरान? सी एवरीवन, द सेम प्रॉब्लम, ओके, सेम प्रॉब्लम जो हम देख रहे थे, क्या है वो? Same problem that we were seeing. Let's assume these blue people are, these dots are people. उनकी मुंडी दिख रही है ऊपर से, हम देख रहे हैं, है ना? टोपी पहने ब्लू कलर का, ठीक है ना? और ये ऑरेंज वाले ऑरेंज टोपी पहन के लोग खड़े हैं, और इनको हमने बोला है जो डायबिटिक हो वो सारे एक साइड खड़े हो, जो नॉन डायबिटिक हो सारे एक साइड खड़े हो। नो सुपरवाइज्ड, हाँ, क्यों टोपी पहना दिया ना हमने। अगर वो टोपी नहीं होता, सारे बिना टोपी के होते, काले काले दिख रहे होते सब, then it would be unsupervised. But now it is labeled because we have orange and blue. Right? We know which are which class. This is the sample data, training data that is given to us. Our task mathematically is to draw a line here. ठीक है? So that इस लाइन का यूज करके लेटर ऑन अगर कोई नया आए तो उसको हम बोल सकें भाई तू लाइन के उधर रहेगा या लाइन के इधर रहेगा। करेक्ट है ना? सो इफ वी कम हियर एंड सी, ओके, जस्ट बैठो सर, बैठो आप, बैठो, अरे आप बैठो आराम से, अरे आप बैठो आराम से, मेरे को खाली खड़े खड़े काम है। सो इफ वी सी हियर एंड आई टेक द माउस ऑन दिस, you can see that the weight is minus 0.14, randomly decided by the neural network. Okay, if I go down, we can see the weight is 0.13. This is also randomly decided by the neural network. And if I come here, it will say bias B, it is 0.10, randomly decided. Now we can see there is no line over there, line nahi hai, right? When I go ahead and train, click on train, रिमेंबर द वेट, इसका वेट क्या था 0.14, जस्ट एक का रिमेंबर करते हैं, माइनस 0.14, राइट? नाउ व्हेन आई क्लिक ऑन दिस रन एंड पॉज, वेट इज minus 0.66, and we can see that a line has been drawn here to separate it. All right, if I click on continue, मैंने stop कर दिया था उसको, that weight will change again, so it's now minus 0.175, and the line is more optimized. Okay, so slowly and slowly with this number of epochs it will be optimized. अब एक लेवल है, उससे ज्यादा ऑप्टिमाइज तो हो नहीं सकता है, तो वहां पे रहेगा वो। All right, so that is how this line can be used to separate both. Now this is a simple task of separation. Sometimes what happens that the data is complicated like this. Now this type of data we cannot separate by just one single line. We cannot draw a single line to separate it. Possible है क्या? नहीं है। मिनिमम कितने लाइन लगेंगे? Correct, sir. Minimum of 3 lines to draw a closed boundary, right? So we can take 3 lines. 1, 2, 3. One line equation, second line equation, third line equation. All right. And if we click on play, you can see that there is a triangular shape boundary. Right? This one has this line. This one has this line. This one has this line. All right. And फिर तीनों मिलके ये बना दिया. All right. So neural network is just about line. अगर linear regression master हो जाता है, neural network is nothing. It's very simple. Got it? Correct. Correct answer. कहीं गलत बोला तो बता दीजिए. Okay. It can even do more. Now this will need 4 lines. We need 4 lines. Okay. And we can classify. Slowly it will optimize the lines. To reach an accuracy. I think it has. Just let us refresh this a little bit. Now this is done. Got it? Okay. So that's the basics of neural network. How a neural network works. By using perceptron, we can combine. यहाँ पे कितने perceptron लगे? अपने 4 perceptron लगे हैं, है ना? हर एक perceptron एक linear equation को solve करता है. And by solving multiple combination of those linear equation, complicated tasks can be achieved. Correct? Let's see how we can do this in code. सोने के लिए तैयार हो जाओ सब लोग, है ना? एक अच्छी नींद आएगी कोड देख के. नहीं आएगी, मैं ट्राई करूंगा कि ना आए, बट कांट गारंटी. ये पता है सबको? Colab. How many of you know about this Colab? Except CTTC faculties. आपको मैं नहीं बताया. Okay. See, sir. Whenever we are about to teach, since you all are faculties, right? So whenever you are about to teach machine learning, artificial intelligence, or not just this, even Python programming, the biggest headache is Python कहाँ से install करें? बच्चों के पास पाइथन इंस्टॉल्ड नहीं है, बच्चों के पास सिस्टम नहीं है, या उनके सिस्टम में इतना हाई एंड सिस्टम नहीं है कि पाइथन चल पा रहा हो, न्यूरल नेटवर्क डीप लर्निंग चल पा रहा हो. तो क्या करेंगे? हाउ विल दे प्रैक्टिस? कोलैब इज द सॉल्यूशन. कोलैब गूगल देता है हमें. गूगल कोलैबोरेटरी नाम है इसका. ठीक है. गूगल प्रोवाइड्स अस फॉर एकेडमिक पर्पस एंड नाउ इट इज यूज्ड फॉर इंडस्ट्रियल पर्पस ऑल्सो. ऑलराइट. I mean, I use it for industrial purpose as well. तो Google Colab एक cloud installed Python है, जहां पे over the cloud we can access Python and all its libraries and all its functionalities. ठीक है. तो just Chrome में अगर हम Colab open करेंगे तो हमारे पास Chrome में Python मिल जाएगा. We can do Python programming and we can do all sorts of machine learning programming on the cloud for free. So it doesn't charge anything. And also on Colab, what we will get is the power of GPU. So we can go to connect to a hosted runtime. If we connect, it says connecting. Let it connect. It will take some time to connect. पहले इतना टाइम नहीं लेता था, अभी इसको बहुत लोग यूज करने लगे हैं तो थोड़ा टाइम लेता है. And it also depends on the net speed. So once it is connected, we get 12 GB of RAM and 107 GB of hard disk on cloud. अब हमारे मेरे इस सिस्टम में, जिस सिस्टम में ये कनेक्टेड है, उसमें 8 GB का रैम है. ऑलराइट, बट वी गेट 12 GB ऑफ रैम एज अ फ्री रिसोर्स. ऑलराइट, and if that 12 GB of RAM is not sufficient, it will automatically increase it to 16 GB RAM. All right. So while processing large amount of data in machine learning, we require a lot of RAM space, and we also require CPU space. That is given to us by Google. ठीक है, इतना फ्री में दे देता है Google. Then what else we can do here? We can go to runtime. We can change the runtime type, and we get all sorts of GPU available. All right. Now, why is GPU required? Anyone? What is GPU? Graphical processing unit. Why it is required? Fast pictures. Not exactly. Parallel processing. Okay. The main reason GPU is required, CPU is not parallel, sequential processing data है CPU. So one CPU is there. Once that CPU is free, then the next process will be done. So it will be done in not in parallel, in sequentially. अब क्या है यहाँ पे, हमें मान लीजिए 1000 पेशेंट, बैक टू दैट प्रॉब्लम, we have thousands of patients data, and of thousands of patients of data we have to make a prediction, then match that prediction with the actual prediction. Then if the actual prediction is matching, then we have to go back and change the weights and biases. इतना काम करना है. अब 1000 पेशेंट के डेटा को एक प्रिडिक्शन निकालने के लिए 1 by 1 अगर वो न्यूरल नेटवर्क के थ्रू पास करेगा तो थोड़ा टाइम लगेगा. बट अगर 100 करके हम प्रिडिक्शन एक बार में निकाल लें तो थोड़ा कम टाइम लगेगा. दैट इज द पावर प्रोवाइडेड टू अस बाय जीपीयू. दैट इज वाई जीपीयू इज वेरी नेसेसरी फॉर मशीन लर्निंग और आर्टिफिशियल न्यूरल नेटवर्क, डीप लर्निंग. इनमें जीपीयू बहुत यूज हो जाता है. इट्स नॉट जस्ट फॉर इमेज प्रोसेसिंग या नॉट जस्ट फॉर इमेज कैपेबिलिटीज या अच्छा इमेज क्वालिटी आएगा जस्ट उसके लिए नहीं है, बट रैदर it gives us the power of parallel processing. All right. So parallel processing can be done here. And that is why we get GPUs for free on Google. So whether our machine has GPU or it does not have GPU, we don't have to worry about. We will get it on the cloud. All right. And we can use that capability. So that is Google Colab that gives us this space. Okay. Let us load one. So let us load one image data set. I'll tell what it is. So MNIST is basically nothing but a data set जिसको बोला जाता है कि it's ABC of computer vision or image processing programming. It is a data set of handwritten digits. All right, it is a data set of handwritten digits. Almost 60,000 image are there. 60,000 इमेज लोगों ने हाथ से ये डेटा इमेज लिख रखा है, मतलब 0 1 2 3 लिख रखा है. एंड आवर टास्क इज टू क्रिएट अ प्रोग्राम जो अपने आप पहचान सके कि ये क्या लिखा हुआ है वहां पे. ओके हो सकता है ना? नहीं हो सकता है? हो सकता है तो करो. आज सीटीटीसी की फैकल्टी को तो मैं बोल दूंगा आ जाओ करो. ओके सो ये डेटा सेट हमने लोड कर लिया यहां पे. लेट्स सी. मैटप्लॉटलिब वो लाइब्रेरी है जिससे हम ग्राफ प्लॉट कर सकते हैं. नॉट जस्ट ग्राफ, वी कैन डू एनी काइंड ऑफ प्लॉट. ऑलराइट, so let's just get one image from the data. And plot it. ओके तो ये है यहां पे. सो बेसिकली ये इमेज है. ठीक है, ये इस एक्स ट्रेन नाम के एरे में, ये एक्स ट्रेन जो है, this X train holds images and Y train holds the corresponding name of the image. Okay, so मैंने इस X train से 0 वाला इमेज को इंडेक्स किया एंड Y ट्रेन में से 0 वाले लेबल को इंडेक्स किया एंड उसको प्लॉट किया इमेज और लेबल को. तो हमें मिलता है कि 0th पोजीशन पे X ट्रेन में 5 लिखा हुआ है. इमेज जो है वो 5 का इमेज है. करेक्ट? एनी कंफ्यूजन? नो कंफ्यूजन. कूल. So let's move ahead and do some data analysis. In this process, I will also be telling you like what are the basic steps or major steps while training a machine learning algorithm or deep learning algorithm. If I say machine learning algorithm, it also includes deep learning algorithms. Okay. So the first step is get the data. The first step, you get the data. Whether you are dealing with any sort of problem, you are dealing with an industrial problem or currently what we have done, currently my last company, Secures of Technologies, they developed a face recognition algorithm, face recognition attendance system for all the government hospital of Odisha. So if you go to Capital Hospital now or some hospital or any other district government hospital, you will see that the attendance is now marked by CCTV camera. We don't even face recognition algorithm या face recognition attendance पहले से था मार्केट में, बट सारे सॉल्यूशन में क्या होता था कि एक डब्बा लगा होता था and that box used to be face recognition enabled and you have to go ahead and stand in front of that box. What my previous company had done the innovation is that they omitted the use of that box by developing an algorithm which can track through the CCTV camera which is already installed in that location. So every hospital, bank, school, everywhere we have CCTV cameras already रहता है पहले से, यहां भी है पीछे, है ना? तो using that CCTV camera footage only to mark the attendance of the person. And now it is being extended to government schools. All right. जो पिछले साल एक 5T ट्रांसफॉर्मेशन, yes sir. Oh, okay. So last year, the government of Odisha came up with that 5T transformation program. Under that only this whole infrastructure was developed. And that project came to OCAC, and from OCAC it came to our company, and we have developed. And I was the one who developed the algorithm. So वहां पे क्या होता है, to get the data, we went to each of the government hospital and we collected the face image of some of the staff. All right, not all, because it was impractical to collect the image of all the staffs. We collected image of some of the staffs so that we can train the algorithm for that particular location. For every location, image is different. All right, CCTV कैमरा की कंपनी अलग हो गई तो इमेज अलग आ गया, रेजोल्यूशन अलग हो गया, इमेज अलग आ गया. किसी का कैमरा लाइटिंग में लगा हुआ है, किसी का कैमरा बाहर लगा हुआ है, किसी का कैमरा पेड़ के नीचे लगा हुआ है, सो इमेज अलग आ गया. So we have several variations of that image. So to get to so that, yes, so that our algorithm identifies across all the hospitals, we had to physically go to that hospital and get the image. Without that data, how would we have trained it? All right. So the first step is get the data. We got the data. Then after getting the data, we analyze it. And that analysis step is called exploratory data analysis. All right. We have to analyze like how many data is there, how much data is there. So we can get it by simply checking the shape. So here we says it has 60,000 images. Each image is 28 pixels by 28 pixels. And the image is black and white. This is. Then we have to check that how many images per class are there. For that, we can import Seaborn library. Now, this will take some time to count along for 60,000 classes. Meanwhile, it plots. Now it is taking so long that I think I need to start GPU. Let me start GPU. From runtime, we can go to runtime and change runtime type. And from here I can go to T for GPU. बाकी चीज वैसे ही रहेगा सर, कोई प्रॉब्लम नहीं होगी. अब ऐसा कुछ नहीं है, हम डायरेक्टली भी चेंज कर सकते हैं, कुछ नहीं होगा. So I just went ahead and changed the runtime type. It will connect after some time. So now it is connected to Python 3 Google Compute Engine GPU. Still, this count plot will take some time to execute because from 60,000 it is counting how many 0, how many 1, how many 2, everything. But I cannot use this count plot. I can also do this. ओके, वो ज्यादा टाइम ले रहा था सी बॉन्ड, मैंने उसको लॉजिक से कर दिया तो वो कम टाइम लिया. So basically here we have counted how many images of 0, how many images of 1, how many images of 2, 3, 4 are there. All right. Now what we have to note here that कोई एक क्लास का बहुत ज्यादा नहीं होना चाहिए. Uniform distribution should be there. Otherwise what will happen? अगर हम it is similar to training a student. All right. अब अगर किसी स्टूडेंट को हम क्लास में पढ़ा रहे हैं और उस स्टूडेंट को एक चैप्टर बहुत ज्यादा पढ़ा दिया, साल के 6 महीने एक ही चैप्टर पढ़ाया और फिर बाकी के 6 महीने में बाकी पूरा सिलेबस कंप्लीट किया, तो वो स्टूडेंट क्या करेगा? एग्जाम में कुछ भी क्वेश्चन आएगा, वो जो 6 महीने पढ़ा है उसी में से आंसर लिखेगा किसी तरह बना बना के, करेगा ना? हाँ, it will be overtrained on one class, undertrained for remaining classes. So the same logic goes here. If there will be too many images for just one class and less number of images for other classes, or not just images, if there are samples, total samples are not evenly distributed, the sample for one class is too much and sample for other class is not that much, then the sample for which there are too many samples, the model will try to predict that only. Class imbalance issues or class bias issues बोलते हैं इसको, which is also called overfitting. All right. So in simple terms, ज्यादा इमेज एक क्लास के नहीं होना चाहिए, सारे क्लास के लगभग बराबर. अब एकदम बराबर भी होना पॉसिबल नहीं है, दैट इज इम्प्रैक्टिकल. ऑलराइट. सो लगभग बराबर होने चाहिए. ठीक है. सो वी हैव ऑलमोस्ट इक्वल इमेजेस. किसी का 6000 है तो किसी का 6500 है तो किसी का 6100 है, ऐसा कुछ है तो चलेगा. ऑलराइट. सो दिस इज हाउ द क्लास डिस्ट्रीब्यूशन शुड लुक. लेट अस इंपोर्ट टू कैटेगोरिकल. अरे किधर से आता है यार ये? One of the problem of these libraries are that they always try to change only utils में रह गया वो. हाँ, it is always updated. So two categorical, and we'll convert this y train to n कैटेगरीज भी देने थे अपने को ना. कोई बात नहीं, कोई बात नहीं, मैं यहां से ले लूंगा दोबारा. So we have 10 categories. अब now we will have to import neural net libraries. First, from keras dot layers or from keras dot models, I'm going to import dense sequential. Don't worry, I'll explain this. क्या है ये? You have time. हाँ, हो जाएगा. ठीक जा रहे हैं ना मैम? Okay, we are going for sequential now, so we also should change y train, x train, right? करेक्ट। होगा क्या इसमें ट्रेन? नहीं होगा मेरे हिसाब से। देखते हैं, नहीं होगा तो फिर चलेंगे आगे। पाँच सौ बारह। Categorical cross interpina, ma'am. Thank you. Yes. मैं करूंगा। Don't worry. So now this is the training that is happening now. एंड इसीलिए हमें जीपीयू की जरूरत होती है। अभी तो ये कम हो रहा है, लेकिन कभी कभी दिस ट्रेनिंग विल टेक डेज टू रन। अरे अरे क्या हो रहा है? कहाँ क्लिक हो जा रहा है ये? Now we have reached almost 99.707% accuracy. Let us test it. How I will test it? I will open Paint. Okay, I'll write a digit myself and check correct prediction होता है कि नहीं. But उससे पहले we have to make it 28 pixels by 28 pixels. And with a black background, with a white brush. What? Sorry. ब्रश कलर व्हाइट नहीं, यहां से होगा ना? हाँ. With a white brush and 2 pixels, I'm going to write a digit. Let's see. I write 2. Save it. Save as JPG picture somewhere on desktop. Let me save it in MCCI. Okay. And now ये जो सेव किया मैंने उसको यहां पे अपलोड करता हूं मैं. I'll just drag and drop this here. What? नहीं. क्या भाई? नहीं लिया ड्रैग एंड ड्रॉप, कोई बात नहीं. सो ये डिजिट जेपीजी यहां पे आया. लेट अस रीड इट. Let's check it. Shape 28 pixels by 28 pixels. I want it to be reshaped as 1,784, which is one image and 784 pixels. 28 pixels into 28 pixels is 784. So, okay. And then we can say model.predict the image. We need np dot predict classes हट गया है ना. We need np dot where. See, what is this prediction? First, let me explain. This prediction, we have 9 digits, 0 to 9, right? 9 ही डिजिट होंगे ना, 0 से 9. उसके बाद तो रिपीटेशन है. 10 is 1 0 है ना. So we have 9 digits. This prediction array has 9 numbers. First, second, third, fourth, fifth, sixth, 7, 8, 9 and 10. So 0 से 9 तक 10 numbers. Each of these values is the probability कि वो image किसका है. Alright, उस image के 0 होने की probability. This to the power -11. All right. So ये जो prediction आता है, it is a prediction of probabilities that the image is of which digit. And for every digit we get a probability. From this probability we have to filter out which has the maximum. So I can say earlier it used to give model.predict classes. अभी नहीं देता है. So let me ask. argmax यूज करना है ना. अरे वो मैं भूल गया ना कैसे करना. I'll have to import numpy, right? And then Hmm? Okay. इसमें वन का प्रोबेबिलिटी हाईएस्ट है. What is max? %71, राइट. कोई बात नहीं. क्या? नहीं, रीरन से कोई फर्क नहीं पड़ेगा. It is giving wrong predictions. So what we need is we need convnet here. But anyways, किसी ना किसी को तो सही प्रेडिक्ट करेगा. Let's see. Let's draw something else. मैंने रीशेप कर दिया क्या? So yeah, 6. Now 6 is being predicted as 5. So it is giving not accurate predictions, but we can modify this architecture to improve the predictions. So where to modify? We can go with sigmoid and let us remove some of the layers over here. And let us go with 128 neurons here. Let us change this ReLU to sigmoid. And also the increase the learning rate a little bit. Let us see how it trains. Accuracy is very low, है ना? ना, ये तो बिल्कुल जा चुका है. ReLU will only work. Take one more layer here. Initial architecture itself was correct. Instead of taking ये इसको 6 को 5 प्रिडिक्ट कर रहा है विद एक्यूरेसी ऑफ 86%. नाउ टू improve this, we'll need another architecture of neural network, which is called convolutional neural network. All right, quickly I can do it. If you all allow. करूं या नहीं? पक्का? बोर नहीं हो रहे हो तो मैं करता हूं. पक्का? ठीक है. So let us include convolutional here. From keras.model sequentially रहेगा layers from, or else I should be having a program same का. This is the same MNIST data set. All right. But this, in this program, like I have trained a convolutional neural network. So here we have the dense layers जो अभी हमने करा था, उससे पहले हमने कुछ convolutional layers डाल दिए हैं just to increase its accuracy. Now let me connect it. अरे कनेक्ट किधर गया भाई? अच्छा यहाँ. So here we have an image. Now it is trained properly and it is giving us an accuracy of 99% and validation accuracy of 98%. All right, यानी testing accuracy जो है 98% आया. Now if I upload an image of 3, which I have just written here in my handwriting, and do model.predict, it gives us that 3 as prediction. Let us change it. Validate करते हैं और किसी भी के लिए. For example, I write here, let's say 4. Save. Now 2% inaccurate है तो वो inaccuracy रहेगा. For that we'll have to work more. Here we have image of 4. Let us see what it predicts. 4. All right, let us do with one more just क्योंकि मजा आ रहा है. 8. Okay. हाँ 8 को 2 किया. सो 2% इनएक्यूरेसी है वो रहेगा. लेट्स गो विथ 2. ये बाउंड्री से बाहर नहीं जाना चाहिए क्योंकि वो क्रॉप हो जाता है. टू को 2 किया, घुमा के भी था, है ना. तो देखिए 98% एक्यूरेट है सर, तो 2%. कोई बात नहीं, 415 हो रहा है ना. सो लाइक 98% वैलिडेशन एक्यूरेसी है. यानी वैलिडेशन एक्यूरेसी मतलब होता है न्यू डेटा पे. अब किसी भी मशीन लर्निंग एल्गोरिदम को ट्रेन करने के लिए जब हम ट्रेन करते हैं, जैसे किसी भी स्टूडेंट को हम पढ़ाते हैं, तो स्टूडेंट को हम एक सिलेबस देते हैं और एग्जाम में एक कुछ क्वेश्चन पूछते हैं, राइट. अगर क्या होगा, जो हमने उसको क्लासरूम में पढ़ाया है वही सेम क्वेश्चन अगर हम एग्जाम में पूछ ले तो क्या होगा? आंसर दे देगा, टॉप कर जाएगा, सब टॉप करेगा, है ना, जो एब्सेंट रहता है उसको छोड़ के. बट अगर हम क्वेश्चन एग्जाम में नया क्वेश्चन पूछते हैं तो उसका करेक्ट, उसके लर्निंग का जो असेसमेंट होता है दैट इज करेक्ट, है ना, एक्यूरेट लर्निंग असेसमेंट होगा. सो द सेम थिंग गोज फॉर एनी मशीन लर्निंग एल्गोरिदम, दैट वी हैव टू टेस्ट इट ऑन न्यू डेटा, नॉट द डेटा दैट इट हैज बीन ट्रेन्ड अपॉन. वो डेटा नहीं जो वो 60,000 इमेज जिस पे हमने ट्रेन किया, उसी 60,000 इमेज में से कोई एक इमेज निकाल के अगर हम पूछेंगे तो वो करेक्ट प्रेडिक्शन, वो करेक्ट नहीं होगा. ऑलराइट, दैट इज व्हाई वी हैव टू टाइप्स ऑफ डेटा हियर. वी हैव यस ट्रेन एंड टेस्ट. जब हम यहां पे लोड करते हैं डेटा, so we have train and test. All right, training set is for training. तो हम जब मॉडल को ट्रेन कर रहे हैं यहां पे, जब हम यहां मॉडल को ट्रेन कर रहे हैं, model dot fit, so we give it the training data, we don't give it the testing data. All right, and it calculates the validation accuracy on the testing data. तो क्या होता है कि ट्रेनिंग हुआ, एग्जाम हुआ. सो ये जो है, ये हम कह सकते हैं, ये एक्यूरेसी जो आया है, ये एक्यूरेसी इज द क्लासरूम परफॉर्मेंस एक्यूरेसी. तो क्लासरूम परफॉर्मेंस एक्यूरेसी 99% है, बट एग्जाम में उसकी एक्यूरेसी जो है वो 98% है. So which is the correct accuracy? The exam accuracy, validation accuracy. So we'll have to check the validation accuracy. So this is in general how a machine learning algorithm या deep learning algorithm can be trained. All right. The process is very simple. If once we start doing it, it comes naturally. So now if you have any questions, not on this, but in general. अच्छा, एक चीज मैं रह गया बताना, that quickly I'll get to you because students need to know this. Used what is from a job point of view, okay? From a job point of view, there are two types of job or three types of job in artificial intelligence field. One is data science, data scientist. One more is there, which is very confusing. It is data analyst. All right. Data analyst has nothing to do with machine learning or data science. This has nothing to do with machine learning. Data analysis is completely different field. मशीन लर्निंग के फील्ड में आता है आपका डेटा साइंटिस्ट, एमएल इंजीनियर, एमएल इंजीनियर या एआई एमएल इंजीनियर दोनों बोल सकते हैं. एंड द थर्ड वन इज एमएल ऑप्स engineer. All right. Data scientist will do what? Prepare data. In simple एक लाइन में अगर मैं बोलूं तो इट्स data scientist's job will be to prepare the data. They will collect the data. They will be the one responsible कि कहां से मिलेगा, कैसे मिलेगा, कितना मिलेगा, क्या प्री प्रोसेसिंग होगी, how we will prepare it for machine learning model. AI ML engineer will make ML model, train, and validate. वैलिडेट मतलब ट्रेन करेगा, टेस्ट करेगा, मशीन लर्निंग आर्किटेक्चर डिसाइड करेगा, न्यूरल नेटवर्क में कितने लेयर्स होंगे, क्या होगा, कौन से मशीन लर्निंग मॉडल को ट्रेन करना है, वेदर इट हैज टू बी लीनियर, लॉजिस्टिक, सपोर्ट वेक्टर मशीन, न्यूरल नेटवर्क, ये सभी काम मशीन लर्निंग इंजीनियर करेगा, एआईएमएल इंजीनियर करेगा. फाइनली एमएल ऑप्स इंजीनियर क्या करेगा? ऑलरेडी ट्रेंड जो मशीन लर्निंग मॉडल आएगा उसको डिप्लॉय करेगा. डिप्लॉय मतलब किसी वेबसाइट में इंटीग्रेट करेगा, कस्टमर तक, क्लाइंट एंड यूजर तक वो मशीन लर्निंग कैसे पहुंचेगा, उसका सारा काम एमएल ऑप्स इंजीनियर का रहेगा. ऑलराइट. इन इंडिया अगर मशीन लर्निंग जॉब्स की हम बात करें, सो इन इंडिया वी कैन से आउट ऑफ 100% AIML jobs, all right, 40% are for data scientist post. 40% jobs are for data scientist post because India is such a huge market that data generation India में बहुत होता है. 120 करोड़ लोग हैं हम, है ना, और हर लोग कुछ ना कुछ यूज कर रहा है. मोबाइल फोन सबकी जेब में है, ठीक है. 120 करोड़ में 100 करोड़ के पास मोबाइल फोन है, और जितना नीचे उतना बड़ा फोन जो हाँ, मतलब आजकल रोड पे देखेंगे तो छपरियों के पास आईफोन है, हमारी औकात थी खरीदने की, लेकिन वो मम्मी पापा से जिद करके पता नहीं क्या करके ले लेते हैं. यहां रेस्टोरेंट में काम करता है एक लड़का, आईफोन लेकर के है वो. मैं बोला यार क्या कर दिया है, बेकार है सैलरी हमारी, ठीक है. देन only 10% jobs are for AIML engineer. ओनली 10%, वो भी R&D के फील्ड में, ठीक है। पीएचडी स्कॉलर्स अपने अंडर एम्प्लॉय करते हैं, R&D जो आईआईटी वाईआईटी के पीएचडी स्कॉलर्स होते हैं जिनके पास तगड़ी फंडिंग होती है, वो लोग एम्प्लॉय करते हैं AIML इंजीनियर को कि मॉडल बनाओ, नया मॉडल बनाओ, नया मॉडल हम पब्लिश करेंगे या ओपन सोर्स करेंगे, वट एवर वी विल डू। ऑल राइट, या DRDO हो गया, या बड़े और इसरो टाइप के ऑर्गेनाइजेशंस, बड़े ऑर्गेनाइजेशंस जिनके पास उतना रिसोर्सेज है। Remaining 50% jobs are for ML ops engineers. All right. Even my job is mostly ML ops, 10% machine learning, 90% ML ops. All right. That what I will be doing is I will take some machine learning model which is already trained by someone else, उसको थोड़ा बहुत फाइन ट्यून करेंगे, फाइन ट्यून करके अपने अकॉर्डिंग उसको आउटपुट अचीव करेंगे। और ज्यादातर जॉब ये रहता है कि उसको कैसे उस सीसीटीवी कैमरे के फुटेज को लेके इस मशीन लर्निंग मॉडल के थ्रू पास करा के हाउ यू विल डिलीवर इट टू कस्टमर्स। राइट, सो 90% जो जॉब्स अभी, सॉरी 50% जॉब्स जो अभी इंडियन मार्केट में है, इट इज बेस्ड ऑन ML ऑप्स इंजीनियर्स, और ML ऑप्स स्टैंड फॉर मशीन लर्निंग ऑपरेशंस। राइट, तो ये है जॉब का सिनेरियो यहाँ पे। तो अगर स्टूडेंट्स आस्क यू, then you can guide them through this, that if you are doing any course, do a course which is oriented towards machine learning operations. Nowadays what happens that mostly people go for this AIML engineer, इसका जॉब का कोर्सेज इसके लिए भरे हैं मार्केट में, इसके लिए बहुत कोर्सेज है। डेटा साइंटिस्ट, पावर BI सीख लो, टैब्ल्यू सीख लो, ये सीख लो, वो सीख लो, कुछ नहीं होना जाना उससे, जॉब नहीं मिलनी उससे। जॉब मिलेगा यहां से ML ऑप्स से, नॉलेज मिलेगी यहां से। तो इन दोनों को होना है, बिकॉज unless and until you know how your machine learning model is behaving, you will not be able to deploy it. So these two are very necessary. All right, data science is up to statistics, तो बेसिक ऑफ स्टैटिस्टिक्स भी पता है, इट विल बी ओके। बट फ्रॉम अ जॉब पॉइंट ऑफ व्यू, फ्रॉम रिसर्च पॉइंट ऑफ व्यू ये उल्टा हो जाता है। फ्रॉम रिसर्च पॉइंट ऑफ व्यू दिस हैज नो यूज, because a research scholar does not have to go ahead and deploy the model, और कस्टमर को नहीं देना उसको। रिसर्च स्कॉलर क्या करेगा, मशीन लर्निंग मॉडल को ट्रेन करेगा, डेटा साइंस के प्रिंसिपल्स यूज करके प्रिपेयर करेगा डेटा, नए डेटा को ट्रेन करेगा मशीन लर्निंग मॉडल में, पेपर पब्लिश हो गया, काम खत्म। So from research point of view, they don't have to go to clients. But from job point of view, this will be important, because unless and until you give it to the clients or customers, it has of no use. जब तक कोई business use नहीं है तो उसका कोई use नहीं है companies के लिए। All right, okay, so that's all. Any questions? क्या हुआ मैम, चाय पानी का भी इंतजाम है क्या? सो ले आओ। I do not have any institute. I was a part of CTTC. I am a part of CTTC, and I wish I will be forever a part of CTTC. Thanks to Rajan sir and Ritu ma'am. So, no ma'am, because I'm currently employed, so my company restricts those kind of things. And I want to be employed, not a YouTuber. Okay. So here I give to Aparna ma'am. Thank you ma'am. Thank you sir.
We have liked it very much. Yes, the other speakers were too, but this was their personal selection. So we all trusted, and I hope that it was a good session for you too. Now I would like to request our senior training manager, Rajan sir, just give sir a memento. Someone sir, please accept it behalf of us.
And sir is now currently moving to Accenture in the very few days. Yeah. So anybody want any leads, anything, please do bother him. Because he is best in that. He's been helping out our students also so much. So please feel free to contact him. Thank you very much.